Hi guys, this is a video on yield management and let's get started. What is yield management? Yield management is understanding, anticipating, and influencing consumer behavior in order to maximize revenue or profits from a fixed time limited resource. Yield management involves strategic control of inventory to sell the right product to the right customer at the right time for the right price. We have an example here. I have already solved it and let's get started with it. So here is the data for an hotel, and we have the room rates, the room occupancy, and room occupancy during a peak season, say the cricket season, when the cricket is held in the city where the hotel is located and the rooms are in demand. The green data points is the only data we have, and the rest are calculated. Let me tell you how. So, assuming that the room occupancy is expected to increase by 0.5% for every 1% drop in room rate and decrease by 0.45% for every 1% increase in room rate. So, using that, we took the formula for calculating the room occupancy for rest of the room rates, and this is what the formula is. This is the increase in the room rate, and this is the occupancy, that is the existing occupancy of 70%. And that's how we, using these two data points, we calculate the increase in the room rate. Similarly, we do that for the increase in the room rate, which is here. So yeah, for room occupancy we already have two data points, 100% and 65%. The rest are calculated using this assumption. Yeah, so we can get the demand line using the two data points. Two data points are enough to get the trend line or the demand against the room rate. So yeah, what we do is we just select the data points, this, we go to insert, we go to this scatter plot, and select this. We, on selecting this, we add a trend line. If you want to see the equation, you just check this display equation and chart, and there you have it. Yeah, so that's how the chart came up, and we got the trend line for the increase in room rate, the decrease in the demand. That's how the demand works, the demand curve works, right? So this is the trend that we see. Now this was just plain simple calculation of room rates and the occupancy, but there are cost factors included in it as well. So we have the fixed cost, the variable cost, the government levy. These are the costs associated, and then we calculate our profit. So what we do is, for a room rate of 400, we get a revenue of 400 into the percent occupancy. In this case it is 100%, so the revenue is 400%. To calculate the cost, we add the fixed cost, the variable cost, and 30% of the revenue. So that's how we get the cost, and the profit is a simple calculation: revenue minus cost, we get the profit, and the profit is 43% of the revenue. So yeah, but this case is for 100% occupancy, or what we say is, when we know the occupancy is going to be 100% no matter what, say for up to a threshold of $1,000, and we see that there is an increase in the profit as the room rate increases. But this is an ideal scenario. So we consider two scenarios: the current season, the normal season, and the cricket season. We see that these data from the above table, for $400 we have 39% occupancy, whereas it is 100% during cricket season. It is 7% for $600 and 65% during the cricket season. So these two data points here, these two scenarios, during current season and cricket season, we calculate the intercept and the slope, and then using these data points, what we calculate is the occupancy, a plus bx, which is our intercept plus our slope into our revenue. this equation is nothing but the one which we got over here for current situation. This is the line equation, and for the cricket season, this is the line equation. We took the slope and intercept from there and we put the values here, and that's how we got the occupancy. So for a room rate of 493, we got an occupancy of 24%, and for a room rate of 714, we got an occupancy of 45%. But let's check the different scenarios, and so here we used a solver. Say we want to know the profit for if we keep the room rate as $400, what would be the occupancy and what would be the profit. So what we do is we just do data, we go to solver. Here we select this point as our objective. We want to maximize it by changing the cell room rate. We supposedly want the occupancy to be 39%. Okay, solve. Okay, so that's how we had calculated this. For occupancy of 39%, what should be the room rate, and the maximum profit we can earn is 5.30. Okay, so similarly we calculate the different scenarios, and we get that for occupancy of 24%, that is increase of room rate to 493, but we see that the profit is decreased. And similarly, if the occupancy is increased to 80% when the room rate is lowered, we get the profit again decreased to minus 24%. So what we can conclude is that increasing room rate or occupancy does not necessarily increase your profit. Similarly, for the scenario 2 of cricket season, here we take the variable cost to be 20, and we again solve it using the solver. So for 45% occupancy, we get the room rate to be 714, and we have a profit of almost $116. That is a profit percent of 36%. What we see is even when we decrease the room rate, we have a high profit margin. And if we increase the occupancy further, profit percentage decrease. Now we have seen that the increasing room rate or occupancy does not necessarily increase profit. So we need to find a trade-off between the room rate and the occupancy so that we get the maximum revenue. So we move ahead and do the trade-off analysis. For scenario 2, we do the trade-off analysis for the scenario 2. We have the intercept and the slope, we have the room rate and occupancy percentage, and using this equation of line a plus bx, we calculate uh, the occupancy. Here we already have the same fixed cost, variable cost, and government levy. We have the different room rates, and we calculate the occupancy, revenue, cost, profit, and profit per spend. Occupancy is calculated again using the same formula a plus bx, but we use the min function here because we don't want it to exceed the 100% mark, since the occupancy can exceed 100%, since we know that we get 100% occupancy at room rate of 400, and calculate the occupancy for the rest of the room rates, and we calculate the revenue, that is the room rate into occupancy. We calculate the cost as we had calculated earlier, fixed cost plus variable cost into percent occupancy plus revenue into the government levy. So that's how the revenue is calculated. Then we calculate the cost, we calculate the profit, and we get the profit percentage. So these are the varying profits we get. So we need to know and find the point where we get the maximum revenue, and therefore we select this three data point, and we go to insert, we go to recommended chart, and we select this particular chart type, and we get this chart. And what we can see is for the room rate of $500, we get the maximum revenue of dollars 400, and this is how we get the maximum yield at the room rate of dollars 500 for the scenario of peak season, that is the cricket season. Thank you.